Welcome everyone. My name is Dmitry Zinoviev. I am professor of mathematics and computer science at Suffolk University, located in downtown Boston, Massachusetts, United States. My co-author is Alexander Nenko, associate professor from Institute of Design and Urban Studies, St. Petersburg, Russia. We are going to present our study on geosemantic network analysis of Greater Boston neighborhoods. A couple of pictures of these neighborhoods are shown in the right-hand side of the slide. The objective of this study is threefold. First, we are going to develop a framework for geosemantic network analysis of metropolitan areas based on data collected from major social media such as Twitter or Facebook or Instagram. We use this framework to identify unofficial metropolitan Boston neighborhoods using Instagram hashtags. Finally, we are going to look into topics and sentiments associated with these neighborhoods. The overview of our presentation is as follows. We are going to familiarize you with neighborhood structure of Boston. We'll talk about data collection and describe our dataset. We'll show you the geosemantic analysis sequence, including neighborhood extraction and topic extraction. We'll show you the results of our sentiment analysis and finally conclude. Let us first have a look at the structure of the neighborhoods. Boston is often called a city of neighborhoods. Historically emerged districts and independent towns absorbed by core Boston in the 19th and 20th centuries. There are 23 officially designated non-overlapping administrative neighborhoods recognized by the City of Boston. Some of these neighborhoods consist of sub-neighborhoods which are not officially recognized and used only by local residents. The ram that just flew from the upper right corner of the slide shows the position of Suffolk University, my university, in downtown Boston neighborhood. If you look around the core Boston, you will see 25 or so surrounding cities and towns, depending on where you draw the line. These towns and cities chose not to become formally affiliated with the city of Boston for various reasons, mostly historical. It is worth mentioning that the city of Cambridge is not the same as city of Boston. In particular, it is not a part of the city of Boston. So MIT and Harvard University are not in Boston, they're in Cambridge. There are about 370 fine granular neighborhoods within Route 128, which has been traditionally considered the boundary of metropolitan Boston. Again, we've got a flying ram that nicely landed in downtown Boston neighborhood. This is the location of Suffolk University, where I work. Neighborhoods in Boston differ from their neighbors in many ways. In the first place, by ethnicity. There are neighborhoods with predominant Vietnamese population, Haitian population, Jamaican, Polish, Jewish, Honduran, Colombian, Russian, and so on. They differ in use. Some neighborhoods are mostly residential, some are industrial, some are financial, and some are recreational. The list is not closed. Some neighborhoods differ in resident income level, so we can find poor neighborhoods, relatively poor neighborhoods, relatively rich neighborhoods, and pretty much everything in between. And of course, neighborhoods differ in their history, mostly in ways they became or did not become parts of Boston conglomerate. So let's have a look at some of these neighborhoods at a close distance before we engage in digital studies of them. In this slide, you see two pictures taken in the oldest and in the newest Boston neighborhoods. On the left, there is a picture from South Seaport. That used to be a very dense and intense industrial area, as the name suggests. Now it is the newest and rapidly expanding residential and commercial area, and little is left here that would remind us of the industrial past of this place. On the right, we have Beacon Hill, which is the oldest residential part of historic Boston. This is a part of the Boston that resided on three mountains, three tall hills in downtown Boston. Only one hill survived. the Beacon Hill. The other two have been excavated to make more land for Boston. In this slide, we have two suburbs, white-collar, vibrant Brookline, which is fully surrounded by Boston proper and proudly refusing to become a part of it for the reasons unknown to me, on the left. On the right, there is a city of Lynn, the northern neighbor of Boston. It is a blue-collar city with large Latino population. Finally, two more pictures, one from Riviera Beach, famous oceanic beach town, just as the name suggests. So we have wonderful sand beaches here. On the right, we have historically black neighborhood, New Bern Square, which used to be known as Dudley Square until very recently. I believe it has been renamed a couple of months ago. Now that you are familiar with Boston, the city upon a hill, as it is often referred to, let's talk about data that we collected to digitally study Boston neighborhoods. The data came from Instagram, and it was collected between September 10th, 2016 and February 1st, 2020, over the course of 6 months. Most of the data have been collected in January and February, but we decided to keep the earlier posts as well, because getting data of Instagram is not necessarily the easiest exercise. It does not have a very friendly interface, so we thought that once we got these earlier posts, it would be a shame to throw them away. For each neighborhood and locality out of 371 identified, we collected about 200 most recent posts. This is not necessarily the fairmost coverage of the neighborhoods, because some of them are smaller, some of them are bigger, some of them are more important, some of them are less important, but lacking comparative information, we decided to keep the sample size the same for each of the neighborhoods. So altogether, we got 75,404 posts and first comments to those posts. The comments actually serve as captions to the photographs. 66,000 of the posts had hashtags, and those posts were the most precious for us, because as you will see later, our study is based on the hashtag analysis rather than on plain text analysis. It is important to underline that all the data that we collected are from the pre-coronavirus times. If we collected the same kind of data again, we would probably see a very different picture, much grimmer and much sadder. So we have a unique opportunity to look back into the world as it existed before coronavirus. Here is a sample post with hashtags. The post has been collected from the neighborhood called Boynton Yards in the city of Somerville. It is a northwestern neighbor of proper Boston. It used to be a huge railroad yard with a lot of tracks, turntables, and steam engines. Now it is being redeveloped into commercial and residential area. As you can see, almost every other word in the post is a hashtag, and these hashtags, as I said earlier, are the most valuable for us. We are going to use them to build a geosemantic network. The next stage of the project, we are going to use our collected data to build a geosemantic network of Boston area neighborhoods. Let's start with building a network of hashtags. It is going to be a weighted network, so hashtags will be connected with edges of different thickness, so to speak. An edge connects two hashtags if they are used together in one comment. Number of concurrences is the weight of that edge. The more often two hashtags happen in the same comment, the heavier is the edge that connects the two comments. After extracting all hashtags from all comments in our dataset, we obtained 137,000 nodes. In other words, 137,000 hashtags, different hashtags. They're connected with roughly 3 million edges. Some of these edges are thick, some of these edges are thin. Trust me, this is a humongous network and not easy to process, not easy to make sense of, and possibly not making much sense in general because of so much noise embedded in this network. So we reduced the size of the network by identifying the most frequently used tags and the nodes that correspond to these tags. As a result, we selected 5,774 most frequently hashtags for further processing. Some of these hashtags represent locations, some of these hashtags represent places, some of these hashtags represent things, some of these hashtags represent something else. So we separated all hashtags into three major groups. In the first group, we have hashtags that represent various locations, in particular neighborhoods. We had to manually curate the list of locations. First, we had to identify the locations. And second, we had to remove locations that were out of Metro Boston, such as Washington, D.C., Seattle, European places. London happened a couple of times. We also had to combine the hashtags that represent the same location. Unfortunately, Instagram, just like almost all other social media websites, do not have standardized taxonomy for locations, and people often invent tags on the flight. So here are some examples. We have a tag Peabody Square that corresponds to Peabody Square in the town of Peabody, most probably, or perhaps in some other town. We have hashtag Roxbury that corresponds to the town of Roxbury, rather a neighborhood of Roxbury in Boston. We have a hashtag Powder House that refers to Powder House in Somerville. Surprisingly, or rather not surprisingly, the same Powder House can be referred to as Powder House Square. So Powder House and Powder House Square refer to the same location. It may or may not be possible to unify these two tags automatically. Anyway, we decided to do it manually. Washington, D.C., or rather Washington, is crossed out because we know that this Washington does not refer to Washington Street in Boston, but rather refers either to the state of Washington or to the city of Washington in District of Columbia. How do we know? Because we looked at other tags that happen together with this hashtag. And by looking at the associations between the tags, we realized that this Washington is not related to Boston geography. So this is the first group of hashtags, hashtags that represent locations. The other group is hashtags that represent technology that was used for taking pictures. Again, it was manually created and removed. Some examples from this group: Nikon USA. This hashtag is placed by Nikon photographers to express their pride in their cameras. Hashtag photos, well, I do not believe it means anything at all, because on Instagram, everything is a photo. Well, almost everything. I don't believe there is any need to mark anything with this hashtag. Hashtag Instagram is yet another mysterious hashtag. If you post a picture to Instagram, why mark it as posted to Instagram? Isn't it already on Instagram? Well, you'd think it is, but nonetheless, some people still use this hashtag. All these hashtags that represent technology used for taking pictures and for storing pictures, for filtering pictures, have been removed. Finally, everything else must be hashtags that are neither locational nor related to technology. We call them semantic tags. They represent users, emotions, businesses, random objects, and pretty much everything which is none of the above. Here is an example of applying the reasoning from the previous slide to the Instagram post that I already showed you before. So we have locational tags such as Massachusetts, Boston, Somerville, Boynton Yards, Greater Boston, and South Street, and all other tags. Fortunately, in this post, there are no tags related to picture-taking technology. Interestingly, that some of these tags are redundant. For instance, If we consider only posts about things Massachusetts, having the hashtag Massachusetts is redundant. Everything is already in Massachusetts. This tag has to be removed. If it is not removed, it will be connected to or associated with too many other tags. This will not help us understand the structure of Boston neighborhoods. The same goes about hashtag Boston. We are already operating in Boston area. Everything we do is hashtag Boston. Same with Greater Boston. So at the end of the day, the hashtags Massachusetts, Boston, and Greater Boston would be removed from consideration. Somerville, on the other hand, is one of the neighborhoods, rather one of the towns that surround the city of Boston. And there may be some posts related to Somerville as well as posts not related to Somerville. It is important to retain this information. This tag will stay. Boynton Yards and South Street are referring to some locations within Somerville. They carry even more information than Somerville tag alone. So these two hashtags will definitely be preserved. So the network that we constructed, the network of tags connected with edges that represent co-occurrence, is unfortunately not bipartite by design. It consists of tags. All tags are created equal. Fortunately for us, we have a list of locational tags and list of other tags. So we can introduce two parts into this network by hand. Unfortunately, again, several hashtags that represent location can happen within one comment, within one post, and several hashtags that represent entities can also coexist within the same comment or caption. This still makes the network not bipartite. In a bipartite network, networks that nodes that belong to the same part cannot be connected directly with an edge. This is not the case with our network. We can separate our network into two subnetworks, a subnetwork of locations and a subnetwork of semantic tags. That separation has been done after removing some random, noisy location tags and other tags. For location tags, we selected a threshold of at least 75 references. For all other tags, we selected a threshold with at least 25 references. So if a location tag happened fewer than 75 times, or if any other tag happened fewer than 25 times, we did not consider these tags, assuming that they were not significant enough. As a result, we've got a graph, a network of locations with 363 nodes, and a graph of everything else with 885 nodes. Here is an example of a locational graph. The whole graph would be too large to show in one slide. After we extracted the graph from the larger network, we applied Louvain community detection algorithm and identified automatically 17 clusters. For instance, there is a blue cluster here that contains the tags Cambridge, Somerville, Medford, East Arlington, Capitol Square, Arlington, Monotony, Massachusetts, Arlington itself, Lexington, the town where I live. So these hashtags refer to western neighborhood of Boston, to the neighborhood west of Boston. There are some other clusters that refer to other neighborhoods. So for example, this is the neighborhood south of Boston, the town of Dedham, Jamaica Plain, West Roxbury, Roslindale, Hyde Park. These are all Boston neighborhoods to the south of the Boston core. So these extracted clusters do not match official neighborhoods one-to-one. These are the clusters that are defined through the co-use of hashtags by Instagram users. So this is, I would call it a folksonomy as opposed to official taxonomy. Folksonomy, right? So we have 17 large neighborhoods defined by the visitors and posters to Instagram. In the same spirit, we can identify topics by looking at non-locational tags that frequently happen together. Again, we can apply a Low-Wayne community detection algorithm. As a result of this algorithm, we get 28 clusters. And by the way, I should have mentioned on the previous slide, we want to give a name to that cluster rather than call it blue cluster or green cluster. We call it by the most frequent hashtag in that cluster. In the green cluster, in your slide, we have the most frequently used tag foodies. So we call it the foodies cluster. It also hashtags foodie, eats, American food, eater, food porn, breakfast. So obviously this is a cluster about food. Interestingly enough, there is another cluster about drinks. That cluster did not make its way into this fragment, but you can see some leftovers of it. So there is cocktails hashtag, cocktail, whiskey, and trust me, there is much more blue stuff to the left, which just didn't make it into this picture. So now we have two networks. We have a network of neighborhoods and we have a network of topics somehow associated with these neighborhoods. All we have to do now is to combine these two networks in a matrix. So here is a matrix that shows the intensity of non-locational topics in each of the locations. Yellow color represents high intensity, blue color represents low intensity. So if we see a red or a yellow or yellowish rectangle, this means that the corresponding topic, such as barbershops, has strong presence in the neighborhood of Cambridge, at least from the point of view of the people who posted their posts to Instagram. So I already mentioned that Cambridge must be famous for its barbershops. Let me remind you one more time, this is pre-coronavirus data. I'm afraid that most of barbershops are either still closed on Cambridge or have just recently opened. So their presence on Instagram would probably not be as intense as it was before coronavirus. The city of Newton and whatever goes into that cluster is famous for local shopping. The city of Brookline is famous for its happiness, which is a little bit surprising because I'm not even sure how to define happiness. And trust me, I've been in Brookline many times. I did not feel much more happy there than I feel in my hometown. But that's what we get. And the city of East Boston is famous for its aviation. That's not surprising at all. Boston Logan Airport is in East Boston. That's where people go to watch planes, fly planes, meet people who use planes, and do other plane-related stuff. The last stage of our project is calculating sentiment levels. For each neighborhood, we would like to know whether this neighborhood is associated with positive or negative sentiments. So we build a corpus of posts that refers to the tags, to the location tags in each neighborhood. The corpora may intersect because the same post may contain tags that refer to different neighborhoods. To each corpus, we apply VADR, Valence Aware Dictionary and Sentiment Reasoner, a more or less standard sentiment analyzer. This analyzer generates three numbers: level of negative sentiments, level of positive sentiments, and level of neutral sentiments. We are only interested in negative and positive sentiments in this study. So we calculated for each of the 17 neighborhoods, and then we use values P and N, positive and negative sentiment levels, as coordinates in a two-dimensional space. As a result, we get a plot that shows sentiment levels, both negative and positive, for each neighborhood. The radius of the circles here is associated with the standard deviation of the average. So most neighborhoods arouse moderately positive and weak negative sentiments in this area. So we see Brookline, which apparently associates with happiness, but we wouldn't know about it just looking at the sentiment level plot. If we did not know from the previous study that Brookline was a happy place, we would not have any reason to believe that it is. There are two outliers in this chart. First one is Coolidge Corner, Actually, Coolidge Corner is a part of the city of Brookline, and according to this to Vader, it is a pretty happy place. So perhaps Coolidge Corner is a happy place, but the rest of Brookline is not. Incidentally, if you remember the picture of Brookline that I showed you at the beginning of the talk with streetcar tracks, that was taken in Coolidge Corner, apparently not incidentally. There is another outlier in this chart, Massachusetts General Hospital. The hospital arouses strong negative sentiments, which is not surprising at all. Nobody likes hospitals. Even before coronavirus, that was not a happy place to go. During coronavirus times, that must be probably an even worse place to go. It is time to conclude our presentation. The proposed framework can be efficiently used to identify urban and suburban neighborhoods, topics of discourse, and their relationship. This framework is general, as it can be applied not only to Boston, but to any other large geographic area. And it is not specific to Instagram as well. In fact, given that Instagram is very user unfriendly, the network may work much better on Twitter because Twitter has much friendlier data access policy and application programming interface. It may also work with some effort on Facebook and probably on other social media that allow a combination of geographical, locational, and non-locational hashtags. What can we use this framework for, or rather the results of this framework? One use comes to mind immediately. It can be used for automated generation of recommendations for local and out-of-town tourists and prospective migrants that will show them what to expect from certain neighborhoods and where to go in the expectation of certain topics of discourse. Thank you very much for your attention. If you want to reach me, my email address is right under the Suffolk University RAM.